using Newton's equation to solve calculations dealing with the characteristics of light. There are three variables in this equation. The first variable is the letter c. It stands for speed, and speed can be measured in meters per second or nanometers per second. The second variable is a Greek letter. Maybe you haven't learned this Greek letter before, so I have a fable or a story about how this Greek letter got its name. The fable of how this Greek letter got its name. This is a story about Mary. Mary went to school, and when she went to school, she brought her pet with her. And this made the children laugh and play to see Mary's pet at school. But the teacher became very upset and was in a very bad mood and said to Mary, "Your pet must go home." But Mary had a very bad attitude, and she started stomping around, and she decided to kick the teacher's desk, which happened to look like another Greek letter that you might know, pi. What happens to pi if you kick a leg out from under it? Oh, it falls over and turns into this brand new Greek letter. So how did this Greek letter get its name? Well, think about Mary's pet. Everyone knows that Mary's pet was a lamb, duh. And this is how the Greek letter lambda got its name. I hope that now you remember this Greek letter and have an idea of how to draw or write this Greek letter. The end. Okay, so the second variable is lambda. Lambda is an L and stands for wavelength. Wavelength can be measured in meters or nanometers. The third variable in this equation is also a Greek letter. If you haven't seen it before, it's nu to you. Nu is the symbol that chemists use to represent frequency, or how often something happens. Frequency is measured in hertz, which is the same as inverse time. In this case, 1 per second. Waves have different characteristics. An example problem. Red light from helium neon lasers has a wavelength of 633 nanometers and a frequency of 4.74 times 10 to the 14th hertz. What is the speed of this light in nanometers per second? Considering the problem, we see that the wavelength is 633 nanometers per second, and wavelength is lambda. So if we write down the information we know, lambda equals 633 nanometers. Please make sure to include your units so that you can solve the problem with your units correctly. We also see that frequency is 4.74 times 10 to the 14th hertz. Frequency is represented with the letter nu. 4.74 times 10 to the 14th. Hertz is the same as 4.74 times 10 to the 14th per second, which is 1 over second. Okay. The speed of light is a constant, okay, but we're going to solve for it this time, so possibly you want to write it as x. So now we can substitute into this equation. C equals lambda nu, so C equals x, our unknown, or it also equals 633 nanometers times 4.74 times 10 to the 14th per second. Then you can type that into your calculator. So 633 multiplication sign 4.74 EE 14, enter. And after you do all of that work, you should get a value of 3 times 10 to the 17th nanometers per second. 3 times 10 to the 17 nanometers per second. And there you have it. Thank you.